Okay. I don't know. Really? It might be because these laptops have a dodgy microphone.
Yeah. Oh, it's like one or four.
Okay, guys, can I have grab your booklets open to page 28. I'm just gonna ahead of time, guys, if you're someone and you're finding this stuff really easy, I'll just get you to jump ahead. Well, me, mostly. If you're finding this easy, guys, page 136, question 7 is the stuff like we're doing just for this bit today. We won't take too long on this video today, guys. 136. We'll get there in the end. Don't worry. I'm going to start on B, ironically, because it's an easier one to solve than A is.
Yeah.
28. Okay. The questions on this page, guys, it's just to find all the critical points of a quadratic using the methods that we've found so far. Can anyone tell me what one of the critical points of a quadratic is? X and Y what? Intercepts. So if I have a quadratic, guys, I want to know first, where does it cross the x-axis? Where does it cross the y-axis? And where, if again, does it cross the x-axis? The other point that matters is the turning point. And that is what we use completing the square to find. That's the only reason we care about completing the squares, to find the turning point. So I really want you to be all right with that idea that finding the turning point is why we do completing the square. If we didn't need to find the turning point, I would not care about completing the square otherwise. It's one of those maths things that the only reason we talk about it has this one particular practical application. So we want to find the x-intercept, or intercepts, because remember there can be two or there can be none. I want my y-intercept. Yeah, sure. Would one of you guys mind turning the lights off for us? Thanks, Alyssa. You're the realist. We also need to find the TP. Once we have the TP, we're going to plot it on a set of axes. Once we have those three things, we can draw in the dots of those critical points, and from those critical points, we can do a pretty good sketch of what our line should look like, what our curve should look like, I should say. I'm going to do... Which one of these is the easiest, do you guys remember? Y-intercept. Why is the y-intercept the easiest? Because we make x0. When you make x0 in this rule, basically everything disappears apart from the numbers without x. It'll be 10. So to find the y-intercept, what we do is we sub in x equals 0. Because if you have a look at my diagram over on the right here, x is 0 along the y-axis. So if we want to find where it crosses, we just find where x is 0. For the y-intercept it is, yeah.
Then you just sum it.
Yep, 0 squared is 0, 2 times 0 is 0, 4 times 0 is 0. So on this one, we just get the y-intercept equals 10. So my y-intercept is equal to 10. 0, yeah. Remember, you always do the squared first before you times it by anything in front. Now, so that's y-intercept done. That took me a whole of 2 seconds. X-intercept is a bit trickier, because remember, we can have no x-intercept, one x-intercept, or two x-intercepts. Does anyone remember the easy cheat way to find out how many answers there's going to be for that?
Make a positive and...
Yeah, if what is. quadratic equation? Do we have to do the whole thing? Being in the square bracket. So for my x-intercepts, guys, I'm just going to check how many.
If it's below,
Can anyone remember what my discriminant is, what we call it, is?
yeah.
The reason I want you to think about this, guys, is because remember, you don't get given the quadratic formula in exams, so you do need to recall it. Abel? We just want the inside the square root, which is the b squared minus 4ac. In my equation, what is b?
B.
In this particular case, what is b? Specifically -4, yeah. -4 squared. What's a? And what is c? 10. Okay, I'm looking at this straight away, and I don't think there's going to be any answers. The reason why is I know that...
Right, C.
So, yeah. Because 4 squared is 16, I can see straight 4 times 2 is 8, times 10 is 80. 60 minus 80 is going to be a negative number. When there's a negative, there's no x-intercepts. So I'm just going to write down, because this is what my thinking was. Do I even need... Oh, sorry, that shouldn't be -16, should it? Because what's -4 times -4? Yeah. So there we go. So positive 16. So I'm just going to say equals negative. I don't even need to answer that because I can see that the number I'm taking away is bigger than what I'm taking it away from. So therefore, no x-intercepts. Makes it a little bit harder to sketch it, but that's all right. Can you see why the discriminant is important? Because because in my head, because I haven't obviously looked at this problem for like 2 years since I wrote this, in my head, what I was going to go ahead and do is say, okay, well, looking at my A, B, and C, I can factorize this. Because I could factorize that 2 out the front, and then I'd have a monic quadratic left inside a set of brackets. You could have then factorized that, but I would have spent a while trying to figure out what factors worked. But according to what we've just done, there is actually no solution. So it would have been a lot of wasted time trying to look for an answer that wasn't there. Of course, if we did the quadratic formula, we would have found no answer. We're going to do quadratic formula for the next one because it's a bit harder. You can't factorize it. But anyway, that's beside the point. Finding our turning point. What do we got to do? Make 1, 0. You're thinking about x-intercepts still. So this is the one that you missed, the completing the square. So let's have a look, guys. I want to find my turning point. To find my turning point, I need to get into y equals... What does my turning point form look like?
X plus a squared. X plus a squared equals x squared plus 2ac plus a.
Not quite. That's not really that's what we're going to end up doing to complete the square, but that's not specifically... Don't remember what letters are in my turning point form.
Oh.
There's not an A in it. Oh, no, there is an A in it. Sorry, I'd tell a lie. Yeah, so there's an A. There's an A in front of x take h squared plus k. And that will give me a turning point of h comma k. The one that's tricky, that always trips people up, guys, is the h. The h in my rule, if it's negative in my rule, it's positive in my turning point, and vice versa. So even though it's minus in the bracket, it's positive over there. But k matches up. So you just got to remember that little trick. In order to get my rule into that form, we've got to do what Ryland was saying, is match it up to that perfect square. Just because I can't see at the top of my page, can you just read out what the rule is for me again, please, guys?
Right.
10. How do I have so much space? I've zoomed in. So for this one, guys, can anyone see any issues with it's 2x squared. It's not monic. It's easy to complete the square. Sorry. It is easier to complete the square for a monic compared to a non-monic. But looking how I got what? That's just the rule we started with. Oh no, so I asked why is there anything stopping us from just like solving this? What's stopping us from just going straight into it is that there's a number in front of the x squared. Because we've got to get rid of that so that we can look at a simplified version of it, because it's easier to do it with the simple version. No, we'll factorize out this one. So each of these has a factor of 2, guys. So I'm just going to pull 2 out of a set of brackets. When you factorize 2 out of 2x squared, what's left over? X squared. 2 out of minus 4x, minus 2x. And 2 out of 10 would give you 5. Okay. So we want to, for all intents and purposes, guys, we want to only now focus on this inside of the bracket. We'll focus on the whole bracket later on, but for what we're doing now, completing the square, we're only going to look at the insides. We're just going to basically pretend that 2 in the front doesn't exist for the maths we're doing now. It's still there. We're just putting it to one side for the minute. Now, the way we get this into the turning point formula, guys, is it turns out the turning point formula looks exactly like a perfect square formula. And the perfect square is this. X plus a squared equals, and when you expand that out, you get x squared plus 2ax plus a squared. So we want to match what's inside my bracket here. No. A is going to end up being -1.
-2.
Nope.
Oh, yes.
Sorry? So we want, so it would be -6 plus 6. Okay. So for those of you that are still struggling with this a bit, I'll just quickly explain my thought process here. I want to turn what I've underlined there into this. To be able to turn that into that, I need to make what's inside my bracket there look like what that on the right-hand side is equal to. That on the right-hand side is equal to this. They already look kind of the same. They both have an x squared. Yes? They both have some number in front of an x, but this one has 2a and this one has -2. And then they have some number on the right-hand side. We have an a squared over there, we have a 5 over there. So we've got a little bit of work to do to make them look the same. If I say, though, that these middle terms, the -2x and the 2ax, match up, what is the only value of a that works to make those two the same thing? -1. Because 2 times -1 is the same thing as -2. So I'm trying to match what's in my brackets here. Oh, so in my old one, it had like a really big dot when I held my thing over it. Why has I got messages? What is that? Okay. Oh, yeah, that's... So, just hold up. So, yeah, no, I wasn't thinking about the a value. I was thinking of -2. So, -1 squared is +1. We have 5. So, we would want to -4 plus 4. Yeah, we're both wrong. You do it to this one, and then later on you expand the bracket back out. Okay, guys, I'm 3 questions in, and people keep on adding new questions before I've started the first question. So let me get to the questions in order. So, Clarice, we want to make our. I'm trying to point to stuff. We're trying to make our rule look like this. Can you see my mouse there? We're trying to make my rule look like this. That's our goal. At the moment, our rule looks like y equals 2 bracket x squared blah blah blah, which doesn't look like that. What that does look like, though, is a perfect square. So it's kind of like, this is a dumb analogy, it's like building a bridge. I have where I want to be over there, I have where I am here, and I'm trying to find a way to meet in the middle. So I have my equation that I have, y equals 2 bracket x squared minus 2x, whatever, and then over there I have the x plus a squared. I want to get to that x plus a squared. The way I'm getting there is I'm saying, okay, well, if I expand that out like we did in year 9, the answer is going to be x squared plus 2x plus a squared. So that's the middle of our bridge. We're trying to get to that middle step to make what's in my brackets over here, x squared minus 2x plus 5, look like x squared plus 2ax plus a squared. The only way that works is if a equals -1. Because -2 has to match 2a. The only way for 2 and -2 to equal is if a is equal to -1. 2 times -1 is -2. If over on my left-hand side that was -8, a would be -4. If it was positive 20, a would be 10. It's always just half of whatever is in front of the x. Yeah, a is always half of whatever this middle number is. Yep, and we're going to sub that in. So my rule is going to end up looking like this. X minus 1, because a is -1. So I'm just replacing that a with -1, squared, and that will equal x squared minus 2x. What's -1 squared?
1.
Positive 1, that's right. Okay, do my rules now look more similar than they did before? So they've almost met in the middle, but I haven't quite connected my bridge up because there's one term remaining. Well, it's 5. We have 5 in our original one, we have 1 over there. So this is where we get really maths tricky, where we're cheating a little bit, because normally in maths you can't just add something or take something away from equation. You've got to keep it balanced. Normally the way we balance an equation is what we do to one side, we do to the other. But it turns out if I just do the same thing, if I do something to one side, then just do the opposite, so plus 5, take 5, that also keeps the equation balanced. So we're going to do that to keep our equation balanced, but also turn that 5 into a 1. The way I would turn that 5 into a 1 is to -4. So I'm going to pop back over to the left-hand side of my problem here. Yes. Yep. I've just replaced that a with -1 and replaced it in all the other places and solved it. Because if you times 2 by -1, what did you get? So can you see that this is the same, but I want to turn that positive 5 into a positive 1, so I'm going to -4 away from it. Together, those two numbers equal +1. But at the moment, I'm unbalanced. My equation, I've got a +4 to keep it steady. And that, could I have put that +4 outside the brackets, guys? No. Because what's also outside the brackets? Everything out inside this brackets is currently being multiplied by 2. We're just ignoring that for the minute.
Shouldn't it's a negative?
A is -1, yes?
So you do times a for.
Okay, the a and the a squared are different ideas. We figured out the a just to know what our equation should look like in the long form. So we've got to square whatever a is, and that's what we're turning this third number into. Turns out -1 squared is +1, so I want to turn it into a +1.
Right.
Okay. So I'm going to do an extra line of working out here, guys. I don't really need to do this extra line, but I'm just going to go x squared minus 2x, and then I'm going to add this +5 and -4 together to give me +1. plus 4. Okay. Does this perfectly match this? Yep. So if I'm going to call this one A, I'm going to call this one B and C. If C and B are equal to each other, and A and B are equal to each other, what can we say about A and C? They also have to be equal to each other. Yep, exactly. So because those two things are equal to each other, I can then swap them around because they mean the same thing mathematically. There's no difference between them mathematically. So I'm going to replace x squared minus 2x plus 1 with x minus 1 squared. So y equals 2x minus 1 squared. Sorry, that a is a bit close. I just hope you remember where that comes from. Plus 4.
Is it divided by?
It's not divided. I was just underlining that whole thing and saying that's A, the other one's B, the other one's C, just to show that those 3 bits are all equal to each other. So here, let me point properly. Yeah, I can't wait for my actual teacher desk. So I'm just saying that this x squared minus 2x plus 1, I've called that bit A.
Yeah.
That's the same as that, I've called that B, and that is the same as that, which I've called C. So therefore, if that equals that, and that equals that, stands to reason that that and that are also equal. So just on the next line, I've subbed them in. Okay.
So that's just...
No. Goodness no. There's actually one more step. Can I just read off what my turning point is here? Why not? Why not though? I mean, I've told you it's not. Yeah, there's too many brackets. That's exactly right. If I go back to my turning point formula, guys, my turning point needs to look like A in front of a set of brackets plus K. We have an extra set of brackets than that. So remember how I said I'm putting that times 2 off to the side for the minute, and we're pretending like it doesn't exist. Now's the time to remember it does exist and put it back in. So all I'm going to do is expand my brackets 2 through the brackets. 2 times that x minus 1 squared bracket, that's just going to be 2 and then that bracket. That's not going to change. What happens when you do the 2 times 4?
So there, no.
Yeah, I didn't make it. These should have been page each, really. It's my bad.
I don't know.
So then the turning point will be also 1, 8.
Exactly. So my turning point, just give me one sec. My turning point equals positive 1, positive 8. Sorry, you were saying? To 4 to 8. So I'll use this. We have our set of brackets. I just didn't do this because I didn't have room. We had 2x minus 1 squared plus 4. We want it to look like y equals a x plus a squared. Oh, sorry, minus a squared plus, h and k. Looking at this, these two things don't look alike. We have an extra set of brackets in this one. We just got to get rid of it to make it look more like that. So expanding into my brackets, I have this as my first term. This is my second term. So 2 times that equals 2 bracket x minus 1 squared plus 8. And now that does look perfectly like our turning point form. So I can just read off, okay, my turning point's 1, 8.
And you would have brackets.
Well, x is
Is it
just
a negative one?
x can be any value. So
What?
you won't solve for x in these ones.
What?
Unless I ask you to be like, okay, what is it? The only reason we do this whole turning point formula is to find where the turning point is. And you don't need to know what x is to do that. Were you going to ask something, Roland?
Yeah, why is it not -1?
Because our rule is that is our turning point formula, and then that gives us a turning point of
Change.
positive h and k. As to why that works that way, when you do transformations of quadratics, if you add a number, the graph shifts to the left, and if you take a number, it shifts to the right, is basically why that ends up happening, because it does the opposite of what you'd expect. You'd expect adding 5 to the number would shift it positively, and taking it shift it negatively, but it does the opposite. Why that does that, I can't think of off the top of my head. But we'll do some practice ones where we actually have a go at manipulating these formulas, and we'll see that happen. Okay. We've still got to plot our graph on the axes. This is easy though, it takes like 2 seconds. We know, we just put in the turning point, we put in the critical points. We know it has a turning point at y equals 10, x equals 0. So I'm going to put my turning point up here, and that's 0, 10. Sorry, I said turning point, I meant y-intercept. Where is my turning point? 1, 8. 1 across, 8 up. Is this quadratic going to be a smiley or a frowny?
Smiley.
Smiley, because you can tell that the turning point is below the y-intercept, so this has to be the lower point. And it'll look something like that. Like I said, it takes 2 seconds. We're just doing our best estimation. There's no x-intercept. What equals 0? Because the discriminant was negative, there's no x-intercept. It doesn't ever cross the x-axis. So if you look at ours, can you see that it will never go below 1, 8? It's never going to cross that axis. Okay, I know that's taken a bit of time there, guys. We're going to do the one above it. I'm going to do it on the board, I think, just because it'll be a bit easier to gesture and stuff. Do you guys want to have a crack at doing it first?
Yes.
We're split down the middle here. So I will give you a chance to have a crack at it first, but what I'll do, guys, is I'm going to give you a head start, and I'll just give you a tip to start with as well. And the tip is this. For this one, completing the square is going to be a pain because you're going to be working with decimals and fractions. However, I'll give you the tip right now. Because you have 0.5 here, do you want to be trying to factorize this one out to find your x-intercepts? No. Just use the quadratic formula straight up. Straight away, straight in quadratic formula. Don't even think about factorizing to get your x-intercepts. I'm going to give you a couple minutes to have a crack at that. You may. Why? Whose shoe is that?
Oh, what? It's mine.
Why was there a calculator in it?
Because it's also. Don't ask quick. Ask the gym.
Still recording, yes. Never not recording.
So we're not even finding the x-intercepts. It's too.
In this one, you would. In this one, I'm pretty sure there are x-intercepts.
Yeah, there's 2.
Is anyone stuck? Would like a hand to get started?
No. Very easy.
Have I done the roll? Yeah,
How do you
hold up. Let me just pause the recording.